students, today I will discuss the topic hybridization. Before discussing about the hybridization, you should know the definition of hybridization. Actually, the hybridization is a phenomenon in which the valence orbitals of the central atom of a molecule intermix to form completely new orbitals of the same number. There are again, at first I write the definition. There are different types of hybridization which are Sp hybridization, Dsp2 hybridization, Sp3 hybridization, Sp3D hybridization and Sp3D2 hybridization. Today I want to discuss the hybridization Sp. In Sp hybridization, one s orbital and one p orbital of the central atom in a molecule intermix to form the two hybrid orbitals. Sp সংকৰণত এটা অণুৰ মুখ্য পৰমাণুৰ এটা s আৰু এটা p অৰবিটেলৰ মাজত আন্তঃ সংমিশ্ৰণ হৈ দুটা সম্পূৰ্ণ নতুন sp সংকৰিত অৰবিটেলৰ সৃষ্টি হয়। তাৰ কাৰণে আমি এনেকুৱা এক্সাম্পল ল'ব পাৰো যেটো এটা হৈছে বেৰিলিয়াম ডাইক্লৰাইড আনটো হৈছে ইথাইন য'ত কেন্দ্ৰীয় পৰমাণুবোৰত sp সংকৰণ হয়। In BeF2, that means beryllium dichloride, the sp hybridization in beryllium atom takes place. In ethyl or acetyl, in the central atoms are carbons. In both these two carbons, sp hybridization takes place. In case of BeF2, since Be is the central atom, it has atomic number 4. So we can write the electronic configuration like 1s2, 2s2. In n equal to 2 cell, there are p orbitals with the s orbital, is 2s and 2p. But in the ground state, the 2p orbitals are vacant. So in this case, we write the ground state electronic configuration like this, where the electron orbitals can be represented by the square also. And here this is 2s2, 2p is vacant. In the excited state, the electron can jump from one orbital to another orbital having almost equal energy. Here 2s electron will jump to the 2px orbital. Then in the excited state, both these two orbitals are singly filled or half filled. And after that, both these two orbitals can hybridize to form two completely new sp hybrid orbitals. Here, the two orbitals are half filled. Now we know that these two fluorines are the combining atoms with the beryllium atom. Again, we know the atomic number of fluorine is 9. The electronic configuration is like this, where the last two pz orbital is half filled. This beryllium atom now can combine with the fluorine atom with the help of this 2pz singly filled orbital with the hybrid orbital of sp. Since we know that two sp orbital have half filled, the this is one sp hybrid orbital of beryllium, this is another sp hybrid orbital of beryllium containing a single electron, and this is the fluorine 2pz orbital, and overlapping the sp hybrid orbital with this p orbital, we get the sigma bond sp pz sigma bond, and here also this is sp pz sigma bond. As a result, we get the BeF2 molecule where there are two sigma bonds, these two sigma bonds, and the bond angle is 180 degree. Like this, by the sp hybridization, we get the BeF2 molecule. This is called ethylene or acetylene. Here, both these carbon atom is sp hybridized. Now, as we know, in the excited state, it has these are orbitals 2px, 2py, 2pz. This is 2s. In sp hybridization, 1s and 1p will take part. These two will be unhybridized. Or pure. These two will form two hybrid orbitals. sp which will contain two electrons. These two hybrid orbitals, these are two hybrid orbitals of carbon atom. Now these two sp hybrid orbitals will combine with hydrogen. As you know, hydrogen has one electron. This will form sigma bond, and the other sp hybrid orbital will combine with the other carbon atom. sp. Again, one hydrogen, one s orbital containing one electron will form one sigma bond. That means this will be the. That means this sp. That means sp of one carbon atom and sp of another carbon atom carbon sigma bond. This is that means sigma bond. That means there are two p orbitals on each. That means these are two pure orbitals. That means this py and px. That means these two pi bonds, if this is sigma bond, these two pi bonds are formed by this combination of these two. Now, I want to discuss with a suitable example the Sp2 hybridization. Sp2. This is double bond CH2. This is ethylene. Ethylene or ethene. Here, both the carbon atom is sp2 hybridized. This is sp2 hybridized. This is also sp2 hybridized. As the earlier cases, here we get the sp2. That means 1s3p. That means 2p. That means we get in the hybridized state we get 3 sp2 hybrid orbitals of carbon atom. Now these three hybrid orbitals combine with like this carbon to form this CH2 and this sigma bond. This carbon will again uses two hybrid orbitals to form this bond with the hydrogen atom. That means since hydrogen has one s1, so this unpaired electron combined with this unpaired electron to form this and this bond. Again, this carbon atom uses is two sp2 hybrid orbitals to form this two sigma bond. These are the sigma bond. Again, the pi bond is formed by the combination of pure. That means one p orbital having unpaired electron orbitals of carbon atom. These two overlap to form this pi bond. Like this, as you know, in the excited state, the carbon atom has this like this. This is sigma bond. This is hydrogen 1s. This is sigma bond, hydrogen 1s. And this is the hard sp2 hybridization containing one electron. This is the carbon. This is the one of the sp2 hybridization, another carbon atom. This hydrogen 1s of this carbon atom. Ultimately, this will form one sigma bond with hydrogen 1s. That means this is the carbon-carbon sigma bond. Now, sigma bond. Again, the pi bond is formed between the between. This is the pi bond. This is the pi bond. In sp2 hybridization, there are different types of examples or molecules where we can consider the molecules BCl3 or BF3. That means BCl3 is boron trichloride. In BCl3, boron is the central atom and 3 chlorine are the combining atoms. We know that the hybridization only takes place in the central atom of a molecule. Here boron have 5, atomic number 5, where the electronic configuration is like this, where this is 1s, 2 is the inner orbitals having 2 electrons, do not take part in the hybridization. Only 2s and 2p are 2p take part in the hybridization. And in the ground state, this is the configuration. 2s orbital have 2 electrons, 2px1. In excited state, 1 electron from 2s can jump to 2py. It will form the that means 2s half filled, 2px half filled, and 2py half filled. In the next step of the hybridization, in the hybridized state, there are 3 orbitals, that is 2s, 2px, 2py will intermix to form completely new 3 orbitals. These are which have 3 unpaired electrons. Now we know that the chlorine is the combining atom. The electronic configuration of chlorine is like this: 1s2, 2s2, 2p6, 3s2, 3px2, 3py2, 3pz1. That means this half-filled 3pz orbital of each chlorine atom will combine, will overlap with the 3 hybrid half-filled orbital of boron atom to form the 3 B-Cl, that is B-Cl sigma bond. Like this here, these are the 3 sp2 hybrid orbital having the single electron which will overlap. This is the overlapping area. Overlap with the 3pz half-filled orbital to form the BCl3, and in BCl3 the bond angle is 120 degree. sp3 hybridization, where 1 s orbital and 3p orbitals of the central atom take place. I want to take the example CH4, which is methane. Here, the sp3 hybridization takes place in the methane. Like this. This is carbon, this 1s2, 2s2, 2ps, 2p1, 2pz, 1 electron here. This is the ground state. In excited state, the electrons from 2s orbital will jump to 2pz. But for our convenience, the electrons, the orbitals can be designated by the box. That means 2s2. This is the excited state. In the hybridized state, in the hybridized state, these 4 will take part to form the completely new 4 orbitals. These are 4 hybrid orbitals. Now, these four hybrid orbitals containing the single electron is combined with the, that is hydrogen 1s1 orbital to form 4 bonds. Suppose like this. The bond angle is 109.5 degree, or it can be said as 109.28 minutes. That means this is the bond angle, that is the angle between the two closest bond in a molecule. Now this is the sp3 hybridization. In the last class I discussed about the sp2, sp3 hybridization. Today I discussed the Dsp2 hybridization. In Dsp2 hybridization, the different orbitals take part in the hybridization are d orbital and 1 d orbital, 1 s orbital and 2 p orbital. Here the d orbital is dx square minus y square. Let us take the example of this compound, which is called the coordination compound. The name IUPAC nomenclature of this compound is tetracyanonickelate 2 ion. That means this is a square planar complexes. Here nickel exists in the nickel 2 plus state. In this complex, the 4 cyano ligand donates 4 electron pair to the nickel orbitals. That means here nickel is in Dsp2 hybridized state. That means in the neutral state, the nickel have the valence orbital 3d84s2. But in this complex, coordination complex, nickel exists as the nickel 2 plus state. In the nickel 2 plus state, 2 of the 4s electrons will be liberated to form this nickel 2 plus. Here the outer electrons will be 3d8. In the ground state, we have this electronic configuration where the 5d orbitals have 3 electron pairs and 2 half-filled electrons. But we know that this ligand is the strong field ligand. This is called cyano ligand. In the field of this cyano ligand, the nickel 2 plus ion, the 4 orbitals will be available for hybridization, which is 1d and 1s and 2 p orbitals. And the other orbitals, 4 orbitals will be paired up. Now the Dsp2 hybridization will take place, in which the 4 Dsp2 hybridizers will be vacant, which will be filled up by the electron pairs donated by the 4 cyano ligand. The resulting structure of the tetracyanonickelate 2 ion will be square planar like this. This is the square planar structure where the bond angle will be 90 degrees. This is for the Dsp2 hybridization. Discuss the sp3d hybridization. In sp3d hybridization, here 1s 3p, that is 3p plus 1d orbitals take part. Let us take the example of PCl5. We know that that means is phosphorus pentachloride. Phosphorus is the central atom where the sp3d hybridization takes place. We know that the valence orbitals or electron configuration of phosphorus is 1s2, 2s2, there are 3d orbitals, available d orbitals where there is no electrons. That means this is vacant. That means this is in ground state. Ground state. That means the orbitals can be designated by the box. That means these 5d orbitals are vacant. In the ground state, it has 3. This is 2. That means in the excited state, the electrons will run from this to this. That means now in the excited state, hybridization state, that means sp3d hybridization will form this 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Where there will be 5 unpaired electrons. These are the 5 sp3d hybrid orbitals. Now these 5 sp3 hybrid orbitals having 5 unpaired electrons will combine with the half-filled p orbitals of chlorine atom. As you know, the electronic configuration of chlorine is 1s2, 2s2, 2p6, 3s2, 3px, 3py, 3pz. This is the half-filled pz orbital of chlorine atom. That means 5 chlorine atom have 5 3pz orbitals. This will combine with the 5 half-filled sp3d hybrid orbital to form the 5 bonds. Like this, these are the 5 sp3 hybrid orbitals. This will combine with 5 half-filled 3pz orbital of 5 chlorine atom. Where the 5 sigma bonds are formed between this is the pz of chlorine. This is the pz, this is the sp3d. All these are 5 sp3 hybridizers. Here the sigma bonds will form between pz of chlorine and sp3d hybrid orbital of phosphorus atom. Now the structure of PCl5 will be like this. This is the trigonal bipyramidal structure. The bond is 120 degree and this is 90 degree. To discuss the sp3d2 hybridization, I will take the suitable example sulfur hexafluoride SF6. This is here. This is the central atom. Here sp3d2 hybridization take place. As you know, the electronic configuration of sulfur is 1s2, 2s2, 2p6, 3s2, 3p. That means 3p4. Then these are the again 3d is vacant. These are the inner orbitals of sulfur atom. These are the valence orbitals of sulfur atom. The hybridization takes place between these 3 orbitals. That means sp3d2 where 1s and 3p and 2d will combine to form the 6 sp3 hybrid orbitals. Now this is the ground state. Well, this is 3s. These 3 are 3p. These 5. These are vacant. here 1, 2, 1, 1, and here 1, 2. That means in excited state, this is the ground state. In excited state, 2 electrons will travel from these two disks. That means like this. This will have 1 electron jumps from these two disks. That means this is 1 electron from this to 3 disks. That means these are the 6 sp3 d2 hybrid orbitals. This 6 half-filled sp3 d2 hybrid orbitals will combine with the fluorine 1s2, 2s2, 2p(x), 2py, 2pz. That means 2, 2, 1. That means this is the half-filled orbitals of fluorine atom. We have 6 fluorine atoms. The half-filled 2pz orbital of 6 fluorine atom will combine with the 6 half-filled orbital of sp3 d2 hybrid orbitals of sulfur atom to form the 6 sigma bonds like this. These are the p orbitals of the fluorine atom. Fluorine pz. Pz of fluorine. That means like this, we will get the structure of sulfur hexafluoride will be octahedral, where the bond angle will be 90 degree in each case. This is the structure of sulfur hexafluoride, and where the structure will be octahedral. For this hybridization, I take the IF7, that means iodine heptafluoride, as an example, where iodine is linked with the 7 fluorine atom. Here, iodine is the central atom. For this hybridization, I have to see the electronic configuration of iodine. The valence shell electronic configuration of iodine is 5s2, 5p5, and all the 5d orbitals are vacant. Now, in the ground state, this is the configuration of 5s, 5p, and 5d. But in excited state, the 3 electrons from the s and p orbital will jump to the d orbital, and it will now, in this state, the 7 orbitals will be half-filled. That means they have 7 single electrons. That means now in the hybridized state, that means there will be 1s, 3p, and 3d will take part in the sp3d3 hybridization, in which we have got 7 hybrid orbitals having 7 unpaired electrons. Now the 5 fluorine atoms, as we know, the fluorine atom electronic configuration is 1s2, 2s2, 2ps, 2py, 2pz. That means this 2pz orbital is half-filled. The 7 half-filled 2pz orbital of 7 fluorine atom combined with the 7 sp3d hybrid orbitals to form these 7 sigma bonds. All these are sigma bonds. This is the central atom. The resulting structure of the IF7 is pentagonal bipyramidal, where the bond angles are 90 degree and 72 degree.